Hi, my name is Benjamin Doyle, and this is my final project for Python for Data Science at Harvard Extension School, Spring 2018. Here's our staff for the course for the semester. Just as a bit of an introduction, machine learning can be defined as the discipline concerned with the implementation of computer software that can learn autonomously. There are two types of machine learning, supervised and unsupervised. Supervised can be thought of as trained machine learning versus unsupervised as untrained. In the case of supervised machine learning, you create a training and a testing dataset. For this project, I've decided to use a Gaussian Naive Bayes classifier, which is a type of supervised machine learning classifier. The dataset I'll be using is a pop music dataset of Billboard Top 100 music in the USA between the years 1960 and 2010. The dataset was originally part of an article which I found very interesting and would highly recommend reading. The authors took songs from the Billboard Top 100 between 1960 and 2010 and tracked different harmonic trends over time. My question was, could I use these characteristics to train a machine learning classifier to predict when a song was released? Here are the required libraries and files that I'll be using in this video. Please make sure that you have them installed if you're going to try to follow along. Now we're ready to get started with the Jupyter Notebook. First things first, make sure that you import everything that we're going to be needing. As I said before, we're going to be using the Evolution Pop USA main data CSV dataset, posted by Matthias Mock. You can find the URL here or in the PowerPoint. Import the CSV dataset into the Jupyter Notebook so we'll be able to manipulate it. Once you've imported it, take a look at the top rows to make sure that it loaded properly. Looking at the dataset, you can see that we have a lot of information, 269 columns to be exact. Since we aren't going to need all of these columns, we can remove a few of them before we get started. I've chosen to use the decade as our target, so we're going to need to keep that one, but everything else can be removed. This still leaves a lot of columns. We don't necessarily need all of these, but we're going to try them just for a preliminary run with our classifier. Using train test split, we're going to create our training and testing data frames. Let's take a look just to make sure everything loaded properly. Once we've made sure that our training and testing data frames are in the right shape, we're ready to run the Gaussian Naive Bayes classifier. We shouldn't be surprised, but since we've left in most of the columns, the classifier hasn't performed very well. Since our classifier didn't do well with all of those extra columns, we're going to bring it down to just a couple of essentials. I chose to include just the cluster, harmonic topics 1 through 8, and timbric topics 1 through 8. Cluster assigns each song to one of 13 different styles of music. Let's run the classifier again on this smaller number of columns. As we can see, the accuracy has increased, but it's still not ideal. Anything under 50, we might as well be flipping a coin. We may still have too many features in the dataset. Let's try just using the harmonic topics. Next, let's try just the timbric topics. Still not very high. We're not getting much improvement. Looking at the graphs, it seems like not all of these features track very well over time. Some of them don't have very clear trends and aren't going to be very good for using in a classifier. Let's try targeting these unnecessary graphs of data. Let's see if removing the cluster H2, H4, and H7 improves our accuracy. Again, we're getting around 40%. Let's try to be a little more critical of which of these graphs we want to include and which data is going to be helpful for our classifier. Still is going around 40%. It's time to use a bit of a different approach. Maybe the issue isn't that we have too many features. Maybe the issue is that we're ultimately trying to use too many classifiers. There were 5 different decades that were possible. Let's try limiting those down to just 2. Maybe we're approaching this problem the wrong way. Maybe it's not that we have too many features, maybe we have too many classifiers. Let's try limiting it down to just 2 classifiers. In this case, I'm dividing them up whether or not they're over 1980 or under 1980. And finally, it looks like this is starting to work. We've increased our accuracy up to 73%. As you can see, things are looking pretty good. We're definitely getting more accurate predictions than inaccurate. Let's see whether or not getting even more specific is going to help our classifier even more. Here, I defined 5 different classifiers, one for each of the decades. Let's see how each of them do. So there is a bit of a spread across them. 1990 appears to be the most accurate, 1960 appears to be the least accurate. So this seems to be the reason why our classifier for 1990 is working the best. Because there's fewer songs that were released in 1990, it's able to predict most of them to be not 1990. If we compare this to 1960, we can see 1960 is a bit more of an even spread. So even though the accuracy of this model is technically lower, it's actually doing a better job. We see that the higher number of songs in the earlier decades is also the reason that we saw a higher degree of accuracy when we first ran the model, with the songs that were either over 1980 or under 1980. If we move it down to 1970, our accuracy goes down closer to the level of what we saw for 1960 alone. I wanted to see if these results were just because I was using the Gaussian Naive Bayes classifier instead of other ones. So I tested other classifiers using the same 70 division. All the results were very, very similar, so it seems that this was not a unique result just to the Naive Bayes. Ultimately, there might be too much variability in this dataset for a classifier to easily predict. However, I'm happy we were able to engineer the features and targets to increase the accuracy to roughly 65%. Here are all the references that I used for making this video. Thank you for watching.